Correct, sir? A very good morning to one and all present here. Today we will discuss the very important topic in the electrical engineering field, that is the nodal analysis in the DC circuit. Now, what is the objective of the nodal analysis? The objective of the nodal analysis is to determine the potential of the unknown nodes in the given circuit, and it is based on the Kirchhoff current law. Now, what is the Kirchhoff current law? The algebraic sum of the current meeting a node is equal to 0. Now, there are three cases in the nodal analysis. The case 1, when there is no voltage source present in the circuit. Now, suppose we have considered a electrical circuit in which there is only current source present in the circuit. Now, we have considered the two independent current source I1 and I2, R1, R2 and R3. They are three resistances. Now, what is the first step in the nodal analysis? We have to determine the number of nodes in the given circuit. Now, what is a node? Node is a point in the circuit at which two or more electrical elements are connected. So, once you have given a circuit, you have to check the every point in the circuit. For example, this is the connecting wire. Now, this is a connecting wire. So, all these connecting wires represent the same node, because the connecting wires are resistance less and they have all are the equal potential. Similarly, this is also a connecting wire at which there are three elements are connected, and similarly at the bottom all these the points are the same because they all are the connecting wire. It means in this circuit there are three number of the nodes. So this is our step 1. Now in step 2 we have to assign the ground node as a zero potential, and assuming the remaining non-reference node by the voltages V1 and V2. Now these voltages V1 and V2 are arbitrary. Arbitrary means we don't know about their actual potential. The actual direction of the current depending upon the V1 and V2 value. Now we will apply the nodal analysis at this V1 point. Okay. So at this node there are four elements, 1, 2, 3, 4. So there will be 4 current in the circuit. So how you will write down the equation? We will assume this V1 potential will be higher with respect to all other. So what is the current in this branch? There is a current is a I1. So this I1 is basically incoming to the node. Now what is the I2? This I2 current is outgoing from that node. Now current in the resistance is, we will determine by Ohm's law, that is a higher potential minus lower potential divided by resistance value. And similarly here the current will be V1 minus V2 upon R2. So what will be this equation will be I1 equals to I2 plus V1 minus 0 upon R1 plus V1 minus V2 upon R2. So at this node there is only one incoming current, while the current in the resistance always will be outgoing. The reason is that because on a particular node we have assumed that this potential will be higher with respect to all other, then current in the resistance will be always outgoing. So there are 4 current I1, I2, V1 upon R1 and V1 minus V2 upon R2. This is our equation number 1. Similarly, we will write down the equation at the V2 node. There are 3 elements, so again there will be 3 current. So current in this is I2, this I2 is the incoming, and remaining these are the 2 currents are in the resistance. So current in the resistance will be always outgoing. So what is the current equation will be I2 equals to V2 minus V1 upon R2. Because we are writing the equation at V2 node, so we will assume this is the higher with respect to all other. Similarly, the current in the R3 will be V2 minus 0 upon R3. So this is the equation number 1, this is the equation number 2. If we have given the I1, I2, R1, R2 and R3, then we will determine what will be the V1 and V2 by using the Cramer's rule or by the substitution methods. Now once you have solved the equations for V1 and V2, after that you can determine what is the actual direction of the current. For example, if V1 is the higher than the V2, It means actual current flow through the R2 will be this direction. Similarly, from current in the R1 will be this direction. Similarly, the current in the R3 will be this direction. And suppose if the V2 is greater than the V1, in that condition the actual direction of the current will be reverse. Because V2 is higher than the V1, then this direction of the current in the R2 will be reverse. So this is about our first case. Now, case number 2, when a voltage source connected between the non-reference node and the reference node, that is a non-reference node and the reference node. Now suppose we have considered a circuit. It consists of two independent voltage source and there are three resistance in the circuit. Now one voltage source, it is a E1, that is a connected in this way polarity. Another is a E2. Now there are three resistance R1, R2 and R3. Now again, in this circuit, there are two voltage source present in the circuit and these voltage sources are independent voltage. The meaning of independent voltage source means their magnitude is does not depend on other values. Now again, the first step is you have to find out the number of nodes in the given circuit. So again we will check every point in the circuit. At this point there are two elements are connected, so this is the node. Now next is this point where three resistances are connected. Next is this point, there are two elements, and the last is the bottom point at which, because these all are the connecting wires, so they represent the same point. So in this circuit the number of nodes are 4. Now once you have calculated the nodes, then you have to check if this ideal voltage source, that is the source should be ideal. This ideal voltage source, where it is connected. In every circuit, a ideal voltage source has two possibility. One, it is connected between non-reference and the reference node. Another is between the two non-reference nodes. So this is our case number 2, when it is connected between a non-reference and reference node. So this is our datum node as per our step number 2. Select the datum node as a reference node and assume its potential to 0 volt. Then you have to find out what is the potential of these nodes. We will start from this minus to plus. So value of this node is the E1. Similarly, the value of this node, that is from plus to minus. So what is the value of this node is a minus E2. It means if a ideal voltage source, the meaning of ideal means there is no series resistance is present with the E1 and E2. It means the value of that node will be equal to the value of voltage source with their polarity, because here the positive is the upper side and the negative is the lower side. So value of this node will be the E1, while here the E2 is connected in the reverse order. So value of this node will be minus E2. After checking the ideal voltage source, we have to find out how many non-reference. So there is only one non-reference, so that we will assume V1. So in this circuit there is only one unknown, which is the V1. We will apply the Kirchhoff current law at this node. There are three elements, 1, 2 and 3, so there will be 3 current. No, there are all the 3 resistances, so current in the resistance will be always outgoing. So there is no incoming current, so that will be the 0. So what is the current in the R1? That will be the V1 minus E1 upon R1. Similarly, the current in the R2, that is the V1 minus of E2 upon R2. And the current in the R3 will be V1 minus 0 upon R3. So this is our equations. Once you have know all the values of parameter, we can find out the V1. Now again, once you have find out the V1, what will be the actual direction of the current? Suppose the V1 is the less than the E1. in that condition the actual direction of the current will be from E1 to V1, and suppose V1 is greater than the minus of E2. In that condition the actual direction of current through the R2 will be from V1 to minus E2, and similarly the current in the R3 will be this. So it means the actual direction is totally depending upon what is the actual value of the V1, because once we will writing the equations, then these equation will be the with arbitrary directions. Now that is our case number 2, when a ideal voltage source connected between non-reference and the reference node. Now the next case, that is a case number 3, when an ideal voltage source that is connected between two non-reference node, and that is known as a super node. Now for this case, again we will consider there are two voltage sources present in the circuit. Now one voltage source is connected between a non-reference and the reference node, while the other voltage source is connected between the two non-reference nodes. That is given in the figure. This is the E1, this is the E2. Now again for this circuit we will again find out the number of nodes for the given circuit. So we will check every point in the circuit. For example, this is the first node, because all these connecting wire represent the same point. So at this point there are three elements connected, 1, 2 and 3, that is the R1, R4 and E1. Similarly, this is our second node, because at this point there are three elements, R1, R2 and E2 is connected. Now next is this node, again there are three elements are connected, and again this bottom node will be the same point, because all are the connecting wires and they are resistance-less. So in this circuit there are the 1, 2, 3, 4 nodes, and assume this datum node as the grounded, and assume its potential will be 0 volt. Now again you have to check this ideal voltage source where it is connected, because there are two possibilities. The case 1, when this ideal voltage source connected between non-reference and reference node, in that condition the value of that non-reference node is equals to the value of voltage source with the polarity, that is from minus to plus E1. Now what will happen at here, this voltage source is ideal, it is connected between two non-reference node, and that is called as the super node. It means the super node will be always exist when an ideal voltage source connected between the two non-reference node. Now in place of this independent source there may be a dependent source also present, and this is the symbol of the dependent source. Okay, now suppose a dependent source, voltage source, this is plus minus, this plus minus may be at outside or maybe the inside. Okay, according to the name, it is a dependent, it means its magnitude depend upon the some other circuit element. For example, we have written here 2Vx. So it is called as a voltage dependent voltage source. So the name of this source is a VDVS. And suppose I have written the 3Ix. So that is called as the current dependent voltage source, and that its name is a CDVS. So in place of this ideal voltage independent voltage source, there may be the dependent source also present, and in that condition it is also called as a super node. The condition is that both the ideal independent or dependent source, they should be ideal. There should be no resistance present on the left hand side or the right hand side of the ideal voltage source. Now then we will assume the V1 and V2, that is our unknown, and we will apply the nodal analysis at the either V1 or either V2, because at V1 and V2 both the nodes the equation will be same. So that's why we will call as the super node, and we will prove it at both the node the equation will be same. For example, we will first write down the equation at the V1 node. So how many elements are connected? 3, 1, 2 and 3. There is no current source present, so there will be no incoming current. So current in all the elements will be outgoing. So current in the R1 will be V1 minus E1 upon R1. Because current in the resistance will be always outgoing, we will assume that this potential will be higher with respect to all other. Similarly, the current in the R2 will be V1 minus 0 upon R2. Now in these two branches the current we can easily determine, but the problem is this E2 branch, because there is a no resistance present in the circuit. Then question is that how we will determine the current in the E2. Now what will be the direction of the current in the E2? That will be this, from the V1 to V2, because we assume the V1 will be higher potential, but there is a no resistance present here. So how we will determine this current? This current will, when reach at this point, then divide into two paths as per our direction. It means if I know the current through the R3 and R4, and if I added them, I will get this current. So what is the current in the R3 as per the direction? V2 minus 0, V2 minus 0 upon R3 plus current in the R4 will be V2 minus E1, V2 minus E1 upon R4, and that is equals to 0. It means this sum is this current. Now suppose I am writing the equation at the V2 node in place of the V1. Again we will get the same current. How? Now see here, suppose we are writing the equation at the V2 node. So when we will writing the equation at V2 node, again there will be three elements. Okay, then current in the R3 will be V2 minus 0 upon R3, we get this term. Current in the R4, that is a V2 minus E1 upon R4, we get this. And when we writing the equation at the V2, then we will assume this will be higher. Then what will be the direction in the of the current in the E2? That will be from V2 to V1. So what will be this current? Again there is a no resistance present. Then what will be this current when reach at this point, divided into two paths? So if I determine these two current, I will get this current. Now what is the current in this R1? That will be V1 minus E1 upon R1, we get this current. What is the current in the R2? That is a V1 minus 0 upon R2. It means in case of the super node, you can write down the equation at any node, you will get the same equation. You can write down the equation either at the V1 or either at the V2. Now what is a shortcut way? How we will write down this equation? For example, for this circuit, you have to forget the E2. Once you forget the E2, then you have to find out at the V1 how many elements are connected? 2, that is R1 and R2. And at the V2 how many elements are connected? R3 and R4, because we are forgetting. So when we will forgetting, then we will find out the current in the R1, R2, R3 and R4 and add them. Then we will get this total current. So what is the current in the V1 minus E1 upon R1, V1 minus 0 upon R2, plus V2 minus 0 upon R3, plus V2 minus E1 upon R4. This is the shortcut way. You have to forget this E2 and find out the current at the V1 and V2 node and added them as per their directions. Now what will be the second equation? The second equation we will determine, this is the your V1. So V1 is connected to the positive polarity of the E2 and negative is connected to V2. So basically what is the potential difference between that will be V1 minus V2, which is equals to E2. Now why we consider the V1 minus V2? Because V1 is connected to positive terminal of the E2. Suppose this polarity of the E2 is a reverse. The right hand side is a plus and left hand side is negative. In that condition the equation will be V2 minus V1 equals to E2. Again you have given all the circuit parameter value, you have to find out the V1 and V2, and depending upon the value of the V1 and V2 we will determine the actual direction of the current. Now this is our case number 3. Now what will happen in the case number 4? In case number 4, we have assumed that the same case number 3 circuit, but it is not a super node. And when it is not a super node, it means this E2 it will not be the ideal. It means there is a series resistance is a present in with the E2. It may be in the right hand side or it may be in the left hand side. So in that condition, how we will find out the nodal analysis? This is our R4 and this is your R5. Now the earlier step is was the same, only the difference in the case number 3 and case 4 is that we have introduced a resistance R5 in the series with the E2. Now it means this is our same ground node. The potential of this node is the E1, this node is the V1, this node is the V2. So this is not the case of the super node. So once it is not a super node, then how we will write down the nodal equation for this circuit? And when it is not a super node, in that condition the equation at the V1 and V2 both are the different. Now how we will write down the equation? Again same, for the V1 node we assume this is the higher with respect to all other nodes. And all are the resistances, so current will be always outgoing. So current in the R1 will be V1 minus E1 upon R1 plus current in the R2 will be V1 minus 0 upon R2 plus, then we have to find out the current in the R5. Now for determining the current in any resistance, we have to find out its potential difference across its terminal. It means the one terminal of the R5 voltage is V2, but we don't know what is the potential of this node. So we will find out the potential of this node with respect to ground. It means this is our ground node whose potential is 0 volt. So with respect to this ground node, this potential is a V1. So we will find out this potential of the node R5 terminal with respect to ground. So up to this point it is a V1, we will move in this direction. So what is this potential will be V1 minus E2. So the potential of this node is basically V1 minus E2. Why it is a E2 minus E2? Because we have moved from plus to minus. Suppose the polarity is reverse. Left hand side is minus, right hand side is plus. In that condition the potential of this node will be V1 plus E2. Now once we know the potential of this node, then we can find out the current in the R5, that will be V1 minus E2 minus V2 upon R5 equal to 0. So this is the nodal equation at the V1 node, and all are the current in the resistance, so they will be always outgoing. Now similarly we have to find out the current at the nodal equation at V2. So how many elements? There are 3 elements, so there will be 3 current. So what is the current in the R3? That is a V2 minus 0 upon R3 plus current in the R4 V2 minus E1 upon R4 plus, again you have to find out the current in the R5. So we will assume that this potential is higher. So current in the R5 will be V2 minus V1 minus E2 upon R5 equal to 0. So basically these are the 2 equations, and both the equations are the different because it is not the case of the super node. Now once we know all these 4 cases, then we can solve any circuit by nodal analysis. For example, I have considered a simple problem of the circuit at the here, in which the one independent and one dependent source is present in the circuit. Then how we will write down the nodal equation for this circuit? For example, this is the voltage dependent voltage source, and this dependent voltage source Vx is given in the circuit, that is a Vx, and this is the resistance, that is a 2 ohm. Now this is the voltage source, that is a plus minus 10 volt. Now this is the resistance, that is a 3 ohm, 4 ohm and 6 ohm. Now our objective is to find out the potential of all the unknown nodes. So for this problem, we will again find out the steps ki the how many number of nodes in the given circuit. So these all are the connecting wires. So the connecting wire represent the same potential. So this is the first node. Now this is again the connecting wire. So we assume this is the second node. Again they all are the same point. This is the third node, and the bottom, because all are the connecting wire, so they represent the same point. So in this circuit there are 4 nodes. Again, step number 2, select the datum node as ground and assume its potential to 0 volt. Then when any voltage source present in the circuit, you have to check where it is connected. So this 10 volt, it is the ideal voltage source. Why? Because there is no series resistance present here, and it is connected between the 2 non-reference node. So this is our case of the super node. This is our. Similarly, we will go, this is also a voltage dependent voltage source, and this voltage dependent voltage source is also ideal because there is no series resistance. So it is also a super node. It means in this circuit there are 2 super node. One is the left hand side and another is the right hand side. This is the super node 1. So we will write down the equation for this circuit. So what are the unknowns? This is the V1, this is the V2 and this is the V3. So we will apply the nodal analysis at the V1 or V2 or V3 nodes. Now we will apply the shortcut way, because for the first super node case, what will be the equation? Will be V1 minus V2 equals to 10 volt. Because the positive terminal of the 10 volt is connected to V1, negative is connected to V2. So what is the potential difference? V1 minus V2 equals to 10. Similarly, you have to find out the second equation for the super node. So positive terminal of 2Vx is connected to the V2. So V2 minus V3 equals to 2Vx. This is our second equation. Now after writing these 2 equations for super node 1 and 2, we will find out what is the dependent relation of the Vx. So see, where is the Vx? That is the voltage across the 2 ohm. So see the polarity of the Vx. This plus is connected to the V1 and minus is connected to V3. It means as per the polarity mentioned, the Vx will be equals to V1 minus V3. Sometimes the students are doing the mistakes ki they V1 minus V2 and then they divide by 2. Now it becomes wrong. Because why? Because we have to find out the Vx, that is the voltage, not the current. If you will divide this V1 minus V3 by 2, then it becomes current. And it is not possible the Vx is equals to the current, because Vx should be in terms of the voltage, not in terms of the current. Now then we will find out the, so we know basically this is a one equation, this is our second equation. We will put this Vx will be at the here. So what is the equation become? V2 minus V3 equals to twice of V1 minus V3. And so what this equation become? V2 minus V3 equals to twice V1 minus twice V3. So this is our second equation. Now for solving the 3 variables, we have required the third equation. Now how we will determine the third equation? As per our shortcut method that we have already discussed in the case number 3 of the super node. This is our first super node, that is the 10 volt connected between V1 and V2. So we forget about this 10 volt. Then we will find out that V1 node, how many elements are connected? 3 ohm and 2 ohm. So we will find out what is the current at the V1 node. So current in the 3 ohm is the V1 minus 0 upon 3. Similarly, the current in the 2 ohm will be V1 minus V3 upon 2. V1 minus V3 upon 2. This is the current in the V1 node. Okay. Now, what is the current at the V2 node? Because it is a super node case, so we forget about this source and this source also. So there is only one element is pending at the V2 node. So we will find out the current here, that will be V2 minus 0 upon 4. Now go to the other terminal of the super node, that is the V3. So at V3 there are the two elements, that is a 6 ohm and 2 ohm. So what is the current in the 6 ohm? V3 minus 0 upon 6, and current in the 2 ohm will be V3 minus V1 upon 2 equal to 0. This is our shortcut way, because there are two super nodes. So first we forget about this, then we have find out the current in the 3 ohm, 4 ohm and 2 ohm. Then we have to consider this super node, forget about 2Vx, find out the current at the V2 and V3 node and added them. We get this equation, and we observe that this V1 minus V3 upon 2 and this V3 minus V1 upon 2 is cancel out. Simplify this equation and solve all these first, second, third equation by the Cramer's rule, and we get the value of the V1, V2 and the V3 nodes. Thank you very much.